Welcome students in the era of objective question part 1 from the chapter Motion in a Plane. So let's begin with the first question. A body is projected with a velocity u at an angle of 60 degree to the horizontal. The time interval after which it will be moving in a direction of 30 degree to the horizontal is. We have given few options. So now let's move with the solution part. Students, what we are doing, I had taken simple a particle and because of some energy, that body will be moving with initial velocity u. It will be projected at the given angle, which is 60 degree. So given that 60 theta will be 60 degree and alpha is equals to 30 degree. What is the alpha given? So this will be moving in the direction of a 30 degree in a horizontal. Okay. So tan alpha, we know the formula u sin theta minus gt divided by u cos theta. After putting the value of alpha and theta, we get tan 30, we know 1 by root 3 is equals to u times sin 60 root 3 by 2 minus gt cos 60 1 by 2. After a solution, we get u by 2 root 3 is equals to u root 3 by 2 minus gt. So gt is equals to u root 3 by 2 minus u by 2 root 3. After solution, we get gt is equals to u times 2 by 2 root 3. Now 2 will be cancelled out and we get the value of g. T is equals to u by root 3. So t we can get u by root 3 times of g. From option we can say the first option is the correct answer. Next question. A particle projected from the level ground just clears in its ascent wall of 30-meter height and 120 root 3 away measured horizontally. The time since projection to clear the wall is 2 seconds. It will strike the ground in the same horizontal plane from the wall of the other side at distance of 150 root 3, 180 root 3, 120 root 3, 210 root 3. So, we know that x is equals to given here 120 root 3. So, for 0 to p time, this will be 2 seconds. So, 120 root 3 is equals to u cos theta times 2. U cos theta is equals to 60 root 3 when we divide 2 to 120. We know the equation for a second equation of motion or a projectile motion, that y is equals to u sin theta t minus half gt square. This is a for displacement equation for vertical motion or vertical process. Y is equals to comes 30 is equals to u sin theta. T value is given 2 seconds minus half g. 2 square means 4. The value finally we get 30 is equals to u. We can write 2u sin theta minus 2j. From first and second, take the u cos theta and u sin theta and then substitute this value. So finally r is equals to 2u sin theta into u cos theta by g we get, and the result r is equals to 180 root 3 meter, which is an option 2. Moving ahead with the next question. A bullet fired at an angle of 15 degree with the horizontal hits the ground 6 km away, keeping the same velocity of projection for the bullet to attain a range of 12 km. The angle of projection is 15 degree, 30 degree, 45 degree, 60 degree. The correct answer for this question is 45 degree. Now let's move with the solution part. The value of a range we know, u square sine 2 theta by g. Here u is a constant. So r is proportional to directly sine 2 theta. Like as you can see here, keeping the velocity same. So because of that line, I assumed u is equals to constant. So r1 by r2 is equals to sine 2 theta 1 by sine 2 theta 2. r1 by r2 is given 1 by 2 is equals to 1 by 2 of sine 2 theta. The value of theta 1 is given 15. So what I did, I put the value of 15 over here, 15 to the 30, and the value of sine 30 will becomes 1 by 2. From here we can say sine 2 theta is equals to 1. So theta we can take out from this equation, which is 45 degree. And according to this, we have the correct option is option C. Moving ahead, next question we have. In a projectile crosses two walls of equal height h symmetrically as shown in this diagram. Choose the correct statement and given factor is g is equals to 10 meter per second square. The time of flight is 8 seconds. The height of each wall is 60 meter. The maximum height of projectile is 80 meter. All the above. So, solution is, student, we have taken a particular body and throwing with the velocity u. It will take t is equals to 2 seconds. And t is equals to 6 seconds. It will be reaches at this point. First time of flight t is equals to t1 plus t2. So which we can take out 2 plus 6 is equals to 8 seconds. Second, height of each wall is equals to h is equals to half g t1 t2. So t1 is given 2 and t2 6 and g we know 10 I'm assuming. This will become 60 meter and third one is the maximum height of projection which is a h is equals to 9 by 8 t1 plus t2 whole square. This will become 10 by 8 8 whole square 80 meter. According to this, the correct option for this question is option 4. Moving ahead with the next question, a particle is projected with the velocity u root gh so that it just cleared two walls of equal height h which are at distance to h from each other. The time interval for which the particle travels between the two walls is 2 times root of h by g under root of h by g, root of 2h by j, and root of h by 2j. Now let's move with the solution part. We have given this diagram. Time taken to travel from P to Q will be t is equals to u by g, and the value of u we know 2 under root gh by g. Now t is equals to 2 times of h by g. From here we can say the correct answer for this question is option 1. Moving the next question, two coordinates of a moving particle at any time t are given by x is equals to at square and y is equals to vt square, the magnitude of velocity of the particles. Few questions are given here, 2t a plus b, 2 times of a t, under root of a square minus b square, 2t of under root a square plus b square, and the last under root a square plus b square. So let's move with the solution part, students. X is equals to 80 square. So dx by dt we can get the value 280. which is equals to velocity. So y is equals to bt square. Dy by dt is equals to 2 times of a bt. This will be gives the value of a vy. So resultant velocity u is equals to under root vx square plus vy square. Put the value of a vx and vy in this equation and get the result to 80 whole square plus 2bt whole square. After a solution, we get this result 2t we can do take out from this root and inside we get a square plus b square. So from the option we can say the correct answer for this question is option 3. Next, an aircraft is flying at a uniform speed v. If the angle subtained at an observation points on the ground, the two position of aircraft t second apart is theta. The height of the aircraft above the ground is given by, we have given few options. Now move with the solution part. So as you can see, we have 3 corners. Now RQ is equals to Vt by 2. Tan is equals to tan theta by 2 is equals to Vt by 2 times H division. So H is equals to Vt divided by 2t cos theta by 2. A particle is projected with a velocity u, making an angle theta with the horizontal, such that the trajectory just grazes the vertices of the triangle. Then tan theta is equals to cos alpha plus cos beta. Second, cot theta is equals to cos alpha plus cos beta. Sin theta is equals to sin alpha plus sin beta. And tan theta is equals to tan alpha plus tan beta. Let's move with the solution part, student. So from this diagram, as you can see, tan alpha is equals to h by x. If any particle is projected from at any particular angle, okay, at maximum height, its initial velocity becomes 0. So I'm supposing this is a maximum height, okay, and makes an angle alpha from this point y. So tan alpha is equals to h by x. So when we apply the formula that h is equals to x tan theta minus g by 2u square cos square theta times x square. What we applied here, I applied the equation for projectile motion. So h is equals to x tan theta 1 minus x by r. So h by x is equals to tan theta times 1 minus x by r. Tan alpha is equals to tan theta 1 minus x by r. Tan beta is equals to h by x prime. Tan h by x prime is equals to tan theta times 1 minus r minus x whole divide r. If we put the value of a tan beta, like as you can see, h by x prime is nothing but b tan beta. So from equation first and second, we can say that tan theta is equals to tan alpha plus tan beta. It's the equation, it's the option number 4, hence the correct option is 4. Next question is, two slots fire simultaneously from the top and bottom of the vertical cliff with respect to elevation alpha and beta respectively. Strike an object simultaneously at the same point if s is the horizontal distance of the object from the cliff, then height of the cliff is s times tan beta minus tan alpha. Second, s times cos beta minus cos alpha. Third, half s tan alpha minus tan beta, and the fourth 1 by 2 times s cot alpha minus cot beta. Solution is minus h is equals to u1 sin alpha times t minus half gt square. It's equation number 1. So at the maximum height, the value of h, if I'm taking the 0, so u is equals to u2 sin beta t minus half gt square. When we subtract from equation 1 to 2, we get the equation of the value of a t, which is equals to s by u1 cos alpha is equals to s by u2 cos beta. So h is equals to u2 sin beta into s by u2 cos beta. We just put this value and get this result, which is option number 1. Next question, a mass A is released from the top of a frictionless inclined plane 18 meter long and reaches the bottom 3 seconds later. At the instant when A is released, a second mass B is projected upward along the plane from the bottom with a certain velocity. The mass travels a certain distance up the plane, stops and returns to the bottom, so that it arrives simultaneously with A. Two masses do not collide with each other. The initial velocity of B is 7 meter per second, 2.25 meter per second, 6 meter per second, 3 meter per second. Solution is, let initial velocity of B is equals to u. L is equals to 18 meter along the plane acceleration, which is equals to g sine theta. S is equals to ut plus half at square. For A, L is equals to 0 plus half g sine theta t square. T is equals to under root of 2L g sine theta. If we put the value of a t, we get the value of a sine theta, which will be g sine theta is equals to 4. So for B, t is equals to 2u by g sine theta. From here, we can calculate the value of u, which is 6 meter per second. And from this option, we can say the correct option is option 3. Next question we have, the bodies are projected with an angle of projection 30 degree and 60 degree with the initial velocity 19.6 meter per second from the same point. Then answer of the following question, the ratio of maximum height attained is 1 ratio root 3, 1 ratio 1, root 3 ratio 2, 1 ratio 3. Solution we have h is equals to u square sin square theta by 2g. H is directly proportional to sin square theta. So h1 by h2 is equals to sin square theta 1 by sin square theta 2. h1 by h2 is equals to sin square 30 degree by sin square 60 degree, which is equals to, we know the value of sin 30, which is 1 by 2. After doing a square, it comes 1 by 4. Similarly, we will do with the sin 60. Sin 60 value is root 3 by 2. When we do the square, then it will becomes 3 by 4. After solution, we get the value of 1 ratio 3. I hope you understand. Moving with the next question. In the above problem, ratio of horizontal range is 1 ratio 1, 1 ratio 3, 1 ratio root 3 is there in the second option. By mistake I did. Okay, so 1 ratio 3, 1 ratio root 1 by root 3. This will be. Okay, now move with the solution part. R is equals to, we know, u square sine 2 theta by g. So R is directly proportional to, we can say, sine 2 theta. R1 by R2 is equals to sine 2 theta 1 by sine 2 theta 2. That means sine 30 degree by sine 60 degree. Okay, when we do multiplication part, the answer will come 1. That means that correct option for this question is 1 ratio 1. These are the very simple questions, student, but the thing is that you might be prepared for the formulas. Next question, in the above problem, the ratio of a time of flight is, so 1 ratio 1, 1 ratio root 3, 3 ratio 2 or 1 ratio 3. Solution we know that the value of a time t is equals to 2u sine theta by g. So t is directly proportional to sine theta. That means t1 by t2 is equals to sine theta 1 by sine theta 2. As you can see, like theta 1 is given 30 degree and theta 2 is 60 degrees. So for that, we get the result sine 61 by 2, as I told you earlier, sine 60 root 3 by 2. And after solution, we get the value of 1 ratio root 3, which is option 2. Next, in the above problem, the sum of maximum height attained by them is. So students, as you can see, like from one problem, we can create a lot of problems. Okay. But the thing is that the problems formula, if we remember, so things will be easier for us. The first option is given for this 9.8 meter, second 19.6, third 39.2, and fourth 78.4. Next option is like we know h1 plus h2, the summation of maximum height is u square sine square theta 1 by 2g plus u square sine square theta 2 by 2g. If we do common all the part, so u is given, g we know, sine square 30 we know, sine square 60 we know. After solution, we get 19.6 meter. According to that, the correct option is option 2. Next question we have a body projected with velocity v1 from the point A as shown. At the same time, another body is thrown vertically upward from the point B with velocity v2. The point B lies vertically below the highest point. For both the bodies to collide, v1 by v2 should be 1 by 2, root 3 by 2, 2, 1. So let's move with the solution part, student. This is the given diagram. Time of ascent of oblique projectile is equals to time of descent for vertically projected body. As you can see, because of the symmetricity, ascent is equals to descent. So v1 sine theta by g is equals to v2 sine v2 by g. v1 sine theta is equals to v2. So v1 by v2 is equals to 1 by sine theta, which is equals to 1 by sine 30 degree equals to 2. According to this, we have the correct answer for this question is option 3, which is a 2. I hope you understand, student. So today we will, I'll came here with the 15 question. Soon we will come with the more also. Till that, take care everyone. Thank you for watching this video.